Okay, now we're going to talk about nuclear energy, which is where the other half of Connecticut's energy comes from currently. So nuclear energy is created through the process of fission, which is splitting uranium-235 into lighter elements and releasing neutrons and energy. So we do this because nuclear fission releases large amounts of heat. So this process takes place down here in the reactor. That heat is used to generate steam, which powers a turbine. It generates electricity. It's the same process we've seen for coal and natural gas. The difference here is we're using radioactive uranium-235. So these neutrons that are released as it breaks down into lighter elements start a chain reaction and bounce all off of that uranium that is all through the fuel cells here. So radioactivity is referring to the energy given off by the nucleus of a radioactive isotope. For the case of nuclear energy, we use uranium-235. So over time, the radioactive nuclei decay or break down and give off energy. So you don't need fission to do this. It's a natural process. But when we do fission, it happens all at once. So we get a lot of energy. So over time, this process happens. It's called radioactive half-life. So that's the amount of time it takes for 50% of a radioactive substance to decay or break down. For uranium-235, this natural process takes millions of years, so we're speeding it up by using nuclear fission. For example, if we had cobalt-60, which is an isotope which has a half-life of 5.27 years, after 5.27 years, half of this cobalt-60 sample that we had would be gone or decayed. So we're going to practice some of those half-life problems in this topic. Nuclear energy is emission-free. It's used for electricity. That's not how we spell electricity. It's used in nuclear weapons, and it runs a lot of our naval ships. So our aircraft carriers, a lot of them are run by nuclear energy, which means they don't have to fill up as often. Power is generated through nuclear fission of uranium-235, and the process is the same as coal. So France is the biggest percent user, as in most of their energy production comes from nuclear. The US is the biggest megawatt producer, but it's not the biggest total of our energy usage because we're a bigger country. Issues with nuclear energy. So there are nuclear accidents. That's a big environmental problem. We've all heard of Chernobyl. We have an issue disposing the spent fuel rods. It leads to thermal pollution. So this is dumping hot water into another body of water, which raises the temperature and can lead to algae growth and can kill fish species that can't survive in warmer water, and also lowers the dissolved oxygen content of the water. And then in the mining of the uranium, we do have some pollution released. Issues with human health. These environmental accidents can lead to thyroid cancer. Remember this one, circle it, star it, write it down a bunch of times, because if you're ever asked about this in AP, you must say thyroid cancer specifically. You can't just say cancer. Other issues are leukemia, birth defects, and or radiation poisoning. Why we still use it? It produces no air pollution, no greenhouse gases, it's reliable, and it's pretty cost effective. So some nuclear meltdowns that you should be familiar with is 3 Mile Island, which was a partial meltdown due to a testing area. Thankfully, radiation was released, but no deaths or cancer cases are associated with 3 Mile Island. This is in the US on the East Coast. Chernobyl in the Ukraine, formerly part of the USSR. There was a stuck cooling valve, which caused a complete meltdown and explosion. Several deaths, widespread radiation released, still radioactive today. And then we have Fukushima in Japan. This was more recent. Fukushima was a cooling pump failure that led to a total meltdown and explosion due to an earthquake and the tsunami that followed. This led to widespread radiation release and caused increased radiation quantities of ocean species. And that is nuclear energy in a nutshell.